In this problem, we have a right triangle. So we have a right triangle, which is a very important indicator of how we're going to tackle this problem. So hopefully now if we're thinking a right triangle, we're probably going to be working with sines, cosines, and tangents. But we have a right triangle A, B, and C. So let us go ahead. I'm just going to draw a triangle right now, and I'm going to make sure it's right. So I'm going to have an angle here that is equal to 90 degrees, and we have it A, B, and C. Specifically, we know BC is the hypotenuse. So I'm just going to say this is B and this is C, and this would have to be therefore A. So you will have A, B, and C, and we have our triangle. So we've drawn our triangle, and specific because BC has to be the hypotenuse. The length in feet of the hypotenuse is 100. So notice here the length in feet of the hypotenuse is 100, and theta, the measure of angle theta of angle ABC, ABC will be a value of theta, is a function of time. So this actual angle is changing. So we could imagine that at one point, so if I keep this steady at 100, so I'm just going to identify this in blue as 100 feet, this will be 100 feet, you may be able to alter this angle such that this 90 is constant, but this angle may get smaller. As this angle gets larger, this one could get smaller while keeping this hypotenuse constant. So this is a moving part. So this is something that is not constant, it's a moving part. The only value that is constant is the hypotenuse of 100 feet. So notice here that we have a given that theta in terms of time is equal to the function 2t squared minus 5t minus 7. So we have this, which is equal to 2t squared minus 5t minus 7. Excuse me. And this is going to be in radians. So this is going to be in radians. So our angles in radians, our time is in minutes, and we have this function that relates how this angle will move and what it will do based off of this parabolic function. So part A says express the length of the side AC. So I'm going to go ahead and figure out, I want to find AC in terms of an appropriate trig function and t. Okay, so I want to represent the sign AT in regards to a trig function that we'll work with. So I know that I don't want to relate it to my length AB because I don't know what AB is. Right now, I hope this is sort of screaming to us, how can I relate AC, my angle theta, and this constant hypotenuse? So if we recognize this leg is opposite of my angle theta, and the hypotenuse is 100. So we know that we're working with an opposite leg and a hypotenuse. So hopefully we recognize that sine of theta by definition is equal to the opposite leg of a right triangle divided by the hypotenuse. And this is always going to be something that's consistent. And we want to express the length of AC in terms of the appropriate trig function. So AC is the opposite. So we know sine of theta is equal to AC all over the hypotenuse, but the hypotenuse we can actually label as a constant value of 100. So we can solve for AC by cross multiplying. So we get our length AC, which will be equal to 100 sine of theta. But we know theta in terms of t is equal to 2t squared minus 5t minus 7. So in fact, our length AC is equal to 100 times sine of 2t squared minus 5t minus 7. So now we have done what the instructions have asked us. We've expressed the length AC, in terms of appropriate trig function. Appropriate trig function is sine, and a value of t. We cannot leave it in terms of theta because this question specifically asked us for the length of the side in relation to the trig function and t. So now we have completed part A, we are on to part B. Part B states compute the rate of change. This right here, rate of change, a key set of words that says derivative, derivative, derivative. So we want to find the rate of change of the side AC with respect to time. So in reality, what we're doing is that we're going to take the derivative of AC with respect to time. But that's okay because our variable of AC is in fact t, so this is no major issue. We don't have to worry about implicit differentiation because the variable that relates our length of AC is actually given in terms of time. So all we're doing is taking the derivative with respect to t. So taking the derivative of this guy, we're going to keep our 100 out in front as constant. Derivative sine will be equal to cosine of the argument 2t squared minus 5t minus 7. But we're going to have to multiply times the derivative of the inside, the derivative of the argument, which is going to be 4t minus 5. I'll simplify this up a little bit. I'm going to pull that 100 out in front, and I'm going to have 4t minus 5 times cosine of 2t squared minus 5t minus 7. And that is going to be the derivative of this in terms of time. So that wasn't so bad, relatively nice, easy derivative to take, and nothing too complicated for us to do. Part C says compute the rate of change of the side AC with respect to time t when t equals to 7/2. So what this is asking for is that this is asking us for the derivative of AC. So it's finding the derivative of AC with respect to t when t is equal to 7/2. Therefore, everywhere in this derivative that we see a t, we're going to have to plug into 7/2. So we're going to find and plug in, we're going to have 100 times 4 times 7 all over 2 minus 5. I see a t, I plug in 7 over 2 times cosine of 2 times 7 over 2 squared minus 5 times 7 over 2 minus 7. One extra set of parentheses there. I don't need that. So let me get rid of that set of parentheses. One too many. And let us go ahead and simplify. So we're going to have 100. 2 cancels off here, and I get a 2. 7 times 2 is 14. 14 minus 5 gives you a value of 9. So this was 4 times 7/2. That cancels. We get 2 times 7 is 14. 14 minus 5 is 9. So now we're going to have times cosine of 7/2 squared. Be careful, that's going to be 7 times 7/2, which gives you 49/4. This times 2. This will cancel. We'll have a 2 on the bottom, so we're going to have 49/2. So we're going to have cosine of 49/2 minus 5 times 7 gives you negative 35/2 minus 7. So in this circumstance, we're going to have 100 times 9 times cosine of 49/2 minus 35/2 gives you 14/2. 14/2 minus 7. Make sure I did that right. Yeah, 14/2 minus 7. Yeah, 14/2 minus 7. And now we're going to have, 100 times 9. 14 over 2 gives you 7. 7 minus 7 is 0. So we're going to have cosine of 0. I like cosine of 0 because we know cosine of 0 goes to a value of 1. So this just gives us 100 times 9 times 1, which gives us 900. But be careful, we have to have units here. We have the rate of change of AC, the length AC with respect to time. Our length is in terms of feet, and our time is in terms of minutes. So this will be 900 feet per minute. So notice nothing I needed to pull up a calculator for. If this was identifying the relationship of this triangle, so we had to draw the triangle. We had to relate our length AC to our hypotenuse and our angle theta. We translated our length of AC in terms of our angle theta, time, and the hypotenuse. We took the derivative, and then we solved the derivative at the specific time when t equals to 7/2 and found 900 feet per minute.